Hey guys, I wanted to quickly run through the basic functions for you and show what I mean by key points. So I'll be doing them in this order, and so if you know most of these and you want to skip ahead to something, fast forward it until you get there. So the first function that you definitely need to know is y equals 1, and y equals any sort of number. It's just going to be a straight line, and the key points for this is just all of these particular points that 0, 1, and 1, 1, and 2, 1, and 3, 1, and so forth. That's the line y equals 1, a horizontal line. Next is the line x equals 1. And the line x equals 1 is a vertical line. And key points for that would be just any of these nice, pretty points 1, 0, 1, 1, 1, 2, 1, 3. The thing that all of these points have in common is that they all have an x coordinate of 1. And any x equals number line is always going to be a straight up and down line at that number. If I just make it really quick, x equals 5, you'll see it's still an up and down line, but now it's at 5. So those are vertical lines. The next basic function is just the function y equals x, and the key points that would be on this would be points like 0, 0, and 1, 1, and 2, 2, and 3, 3, and in the negatives as well, negative 1, negative 1, negative 2, negative 2. Kind of a nice feature of this function is that you get the exact same x and y coordinates out every time. So every key point is just a number where the x coordinate and the y coordinate are the same. 4, 4. 3.5, 3.5. So that's the line y equals x. The line, or the parabola, y equals x squared, is an important function to memorize. And here the key points are 0, 0, and 1, 1, and 2, and 2 squared is 4. 3 squared is 9, so if I move this a little bit, 3, 9 is another key point. And there's other nice ones on there, but when I say key points, I just mean some points that you ought to have memorized that you can use to sketch something. Also, the same y values, but with opposite x values, are key points. So negative 1, 1, and negative 2, 4, and negative 3, 9. Those are all also key points that are on the x squared function. The square root function is similar to y equals x squared, and that's kind of curved shape, but it's sideways instead of vertical. And some of the key points are there is the square root of 0 is 0, the square root of 1 is 1, square root of 4 and 2, and 9, 3. These are some of the other pretty points that you might see. So it's kind of the same numbers, at least, as y equals x squared, but moved around a little bit. That's the square root function. Notice there's no portion of the graph that's negatives, and that's because negative numbers aren't in the domain of this function. The cubic function, y equals x cubed, is an interesting looking one. It kind of comes up and then flattens out and then curves back up again. Some key points to keep in mind for this one. I would memorize that 0, 0 is part of the cubic function, 1, 1 is, and negative 1, negative 1 is. But then if you have a chance to draw one more nice point, 2 and 2 cubed is 8. So 2, 8 is another key point that the cubic function goes through, and it's kind of opposite on this side. Negative 2, negative 8 is another key point. So there's 5 nice key points for the cubic function. Next on my list is the absolute value function. The absolute value function looks kind of like a V, and some of its key points is it goes through 0, 0, and it goes through 1, 1, and 2, 2, a lot like y equals x. But it also goes through those same numbers when x's are negative. So negative 1, 1, negative 2, 2, negative 3, 3. Those are a handful of key points for the absolute value function. The integer function tends to be a new one for students. The integer function looks like this. It's sometimes called the step function. It's sometimes called the floor function. I like to call it the always round down function. And for any x number, for any x number, you always round down to the nearest integer. And so if x is, say, 1.5, normally 1.5 would be this point right here, but I would round down. 1.5 would become a 1. And so here is the integer function. Some of its key points, I would just use any of these integer points, 0, 0, and 1, 1, and 2, 2, and so forth. And then keep in mind that the steps go horizontally from there. The steps are typically 1 wide and 1 in height, unless there's been some sort of transformation occurred, which we'll learn about later. Another important function is a trig function, the sine of x. The sine of x, its key points are that it goes through 0, 0. Oops, let me add a point here. It goes through 0, 0, and then it's the next key point that I would say is at pi. At 3.14, it goes back through 0 again. And then at 2 pi, about 6.28, it goes through 0 again. These are some key points that it has. Negative pi and negative 2 pi are zeros. Some other ideas is that halfway in between there, it reaches a maximum. The maximums are always 1, and the minimums are always negative 1 for the basic function. And so if you can remember those ideas, 0, 0, pi 0, and kind of halfway in between them, it's a maximum of 1, and halfway between on the other side is a minimum of negative 1. Those are the key points for a sine curve. A cosine curve is related, but it's shifted. And so instead of going through 0, 0, it goes through 0, 1. And the minimums are at pi halves, so 1.5 something, 1.6 something, and at 1.5 pi, and at negative half pi and 1.5 pi in this side. We won't do a ton of that until we study trig later in the year, but those are related, sines and cosine functions. The reciprocal function, y equals 1 over x, is an interesting one. Some key points that I would remember, it definitely 1, 1, and negative 1, negative 1 are some key points. The fact that it has an asymptote, a vertical asymptote at 0, and a horizontal asymptote at 0 as well along the x-axis are some key, not really points, but key ideas. And if you need to be a little bit neater, a little bit more precise for drawing in one of these graphs, I would add a graph or a line at when x is 2, y is 1 over 2, 1/2, and 3 and 1/3, 1/3 for x and 3 up, or 1/2 for x and 2 up. Those are key points, and this is a symmetrical graph, and so those same sort of things work with negatives as well. Negative 2 and negative 1/2. Or negative 1/2 and 2. Those are some other key points that you can use to draw in this hyperbola a little bit more accurately. Then there's a number of graphs that are exponential graphs. I don't have one typed in yet, so I'm going to type in the line y equals 2 raised to the x. And whenever x is in an exponent, you're going to get a graph that looks like this. I'm going to zoom out a lot. Notice it has a horizontal asymptote, and then it pretty quickly grows. And some of the key points really depend on what the base is. In this case, the base is 2, and so a key point would be that it goes through 1, 0, 2, 0, 1, that it goes through 1, 2, that it goes through 2, and 2 squared is 4, 2 cubed, 3, would be 8, 2 to the 4th is 16, and I can't quite see it on here, but 216 would be this point right here. So those points are the key points. Again, it really depends on what the base is, what those key points are, but if you plug in and plot a few of those points, then you should be able to sketch a curve pretty nicely. Again, if you want more precision on this side, this would be 1/2 and 1/4 and 1/8, and you continue to get cut the fraction in half each time, and those are some more key points that you can use. The last function I want to graph today is the log function. There's various types of log functions depending on what base of logarithm you choose. For now, I wouldn't worry too much about what I mean when I say the base of the logarithm. The function I have typed here, y equals log of x, means base 10, and so if you just type the word log of x, then it will create a graph that looks something like this. Let me zoom out so you can kind of see what's going on here. There is no graph when x is negative. You'll learn that the logarithms log function doesn't allow negative numbers in its domain. So it's very quickly, it grows from negative infinity, just skyrockets up, and by the time you've gone from 0 to 1, you've taken and gotten through every single negative number. And now here's definitely a key point, and that is the point 1, 0. And then another key point is, oh, this doesn't look like it's graphed let's graph the natural log, the ln. I need to graph log base 10. How do I do that? Y equals log x 10. Nope. Y equals log 10x. There we go. That's how GeoGebra wants it written in there. So this is the log base 10 function, and some key points that are on it are still the point 1, 0. But the point I was trying to show you earlier, 10, 1 is on here. And the next power of 10 is 100. And if I zoom out to 100 and scroll over here a little bit, you'll see that that's the next nice pretty point. By the time it gets to 100, it's gone through 102. And you might be able to tell already that the log function grows really slowly. It does continue to grow. It will always get slightly higher and slightly higher, but it flattens out and grows very, very slowly. It's kind of like an exponential. An exponential graphs grow really, really quickly. A logarithm is the inverse of that. It grows really, really slowly. And so, anyway, long story short, the points 1, 0, 10, 1, 100, 2, 1,003, those would be some other key points that you would use for a log base 10 function. So those are the basic functions that we'll be needing in pre-calc. Thanks for watching.